Okay, so that brings us to exercise 12.3, where we need to implement a function, plot polygon, that plots the polygon and basically produce this plot. So this is just a line plot where we connect all of these points with lines in order to make the plot. So I just copy paste the call of the function, because I think this is one that asks for a bit of iterative writing. So now with that, I'll just remove this pointless line here, and now I'll call the plot function down here, and then start to implement it. So in order to implement this function, we need to give it the name first, plot polygon, and then we need to remember that the first argument always needs to be self, because when we call the function, the object here we can imagine be transferred in as a function to the function like this, and that means self will be assigned to the class object, to the object of the class. So that's why we need to put self in here, because that is how we will actually later get access to the various variables defined in the class like x and y from inside this function. Okay, so in order to get started on this, I think I'll just insert the number 3, because I want to put in a breakpoint and experiment a little bit. So now when I go up and select debug, it'll call the function or the method on the object down here, and that'll hit the breakpoint, and then it'll stop. Okay, so if I go to the debug console, I got access to the x and y coordinates like this, and this is because I initialized them up here. So in order to just get started on this, I can use the matplotlib library that I imported up here. And I can use the plot function to just plot the x and y coordinate. And I think I will use a black line with points for the data points, just for visual clarity. And now if I run this code, it should produce a plot that looks like this. So we can see that the points are here indicated using the periods. So it's missing a line segment, and that's because it will only plot x and y coordinates given in this list. So the line segment we are missing is the line that goes from 4 to 24 in the x coordinate, and in the y coordinate it needs to connect 16 to 12. So we can imagine that we could fix this if we could somehow take 24 and append it here at the end of the list, and 12 and append it at the end of this list, and then call the function itself here. So what I basically want to do is I want to create some updated x coordinating, updated to append x of 0 at the end, and some y coordinates with the same change, and then I need to call it with these x and y coordinates, and that would actually fix the problem. So how do I do this? Well, how do I take this and append it at the end? Since this is a numpy ND array, kind of got two choices here. I can either do this, keep them as ND arrays and append 24 as an ND array to the end using np.concatenate. That would be one approach. Then it kind of needs a list, and it's a little bit tricky. Alternatively, I can convert these to lists, and then they're a lot easier to append. And I think I'll take that approach. So if I take self.x, then I can use the list method to convert it into a list first. And now it's kind of easy, because if I start by assigning x to the list, like this, then I can get the first element like this, and then I can take x, and then I can just add the first element as a singleton list to the end, and that'll do the trick. So I need to update x to be equal to this. And then I need to do the same for the y coordinates, and that's basically just a matter of changing x to y. Like this. And now if I run all of this code, we can see that x and y has been updated appropriately. So when I run the plot command, called show, maybe I need to close this one. No, it's updated. It'll close the polygon. And I guess in order to produce exactly the same result as before, I would need to remove this period, because now it looks correct. Okay. So I wonder if there is a test for this function. I don't think there is, because it's a little bit messy to test functions that involve plotting. But this is how I think you can solve this exercise, and there are different ways of doing it, and maybe you can think about a way of doing this in a single line, which is certainly also possible. Okay, but best of luck. As long as you accomplish the goal, I think that whether you use 1 or 2 lines doesn't really matter that much.